This is mainly for GCSE higher tier chemistry students and is also useful for A-level chemistry too. So in today's video, I will be explaining what is limiting reagent and the impact of limiting reagent in chemical equations and some calculations involving limiting reagent. So let's crack on. In chemical reactions, reactants react together, form products. So the reaction will carry on until one of the reactant finishes. The reactant which finishes the first is what we call limiting reagent, because this reactant limits the progress of the reaction. So the other reactants are the excess reactants, because at the end of the reaction, some of these reactants will remain excess. Let's look at this with an example. In this example, as you can see on the screen, A reacts with B to form the product C. So here A and B are the reactants. And it's very importantly, the mole ratio. As you know, the mole ratio is very, very important in your quantitative chemistry. So 2 moles of A reacts with 1 mole of B to form 2 moles of C. So the mole ratio between the reactants A and B is 2:1. This is very important, 2:1. So that's the mole ratio the reactants are reacting. Now, we are starting this reaction with 6 moles of A and 5 moles of B. These are not the right moles, these are the starting moles. We are adding 6 moles of A with the 5 moles of B. Now let's see what are the moles of each reactant going to react, and who is the limiting reagent and who is the excess reagent. If you're going to react all the 5 moles of B, we need 10 moles of A, because if you look at the ratio, every 1 mole of B, we need 2 moles of A. It's 1:2. So if you're going to react the B completely, all the 5 moles of B, we need 10 moles of A. Do we have 10 moles of A? No, we don't. So this is not going to work because the moles of A we have is just the 6 moles. So let's look at it another way around. If you're going to react all the 6 moles of A, we need just 3 moles of B, because the ratio between A to B is 2:1. So every 2 moles of A, we need 1 moles of B. So 6 moles of A required 3 moles of B, and we have more than 3 moles. So what is the reacting moles here? The 6 moles of A is going to react completely with 3 moles of B, and according to the mole ratio, you're going to form 6 moles of C as a product. So here, who finishes the first? The A finishes the first. So we are finishing all these 6 moles of A, but we're only using 3 moles of B. So therefore, B is our excess reagent. So in this reaction, A is the limiting reagent, B is the excess reagent. Let's do a question. What mass of sodium fluoride is formed when 2.3 gram of sodium reacts with 2.85 gram of fluorine? As usual, let's write the balanced equation. It's very important in quantitative chemistry to have a balanced equation and the ratios right, so the mole ratios. So the mole ratio of the reactant is again 2:1. 2 moles of sodium reacts with 1 mole of fluorine. In this question, we only been given the masses of the reactants, not the mole. We cannot compare the reactants and the product using mass. We can only compare them by moles. So therefore, as a first step, we have to work out the starting moles of the sodium and fluorine. You know how to convert the mass to mole? Mole equal mass over mR. If you do the calculation, we have 0.1 mole of sodium and 0.075 moles of fluorine. If you're going to react all of the 0.075 moles of fluorine, we need 0.15 moles of sodium according to the mole ratio. But we don't have 0.15 moles of sodium. Therefore, it's not going to work. If you look at from the other side, if you're going to react all of the 0.1 mole of sodium, we need 0.05 moles of fluorine according to the mole ratio. This can work because we have enough fluorine for that. So the reacting moles in this equation, it's 0.1 mole of sodium. It's going to react with 0.05 moles of fluorine. At the end of the reaction, we have no sodium left and 0.025 moles of fluorine left over because it's an excess. And according to the mole ratio, we're going to have 0.1 mole of sodium fluoride is formed. The question was asking the mass of sodium fluoride. Using the mole equal mass over mR, we can work out the mass of the sodium fluoride. In this case, is 4.2 gram. So that is our answer. So if you look at this equation, here the sodium finishes the first, and the fluorine is going to be excess at the end of the reaction. And therefore, fluorine is our excess reagent, and the sodium is our limiting reagent. In quantitative chemistry, the balanced equations and the mole ratio of the reactants and the products are very important. All your calculations depends on this. So make sure the equation is balanced and you're following the right ratio. Hope you understand the limiting reagent and how it affects the chemical equations. Until I see you in another video, bye.